Physical errors. Acceleration of the galaxies. Astronomical observations have shown that all galaxies are receding from Earth. It turned out that the speed of receding galaxies increases with the distance of galaxies from the Earth, r. The speed at which the galaxies are receding is determined by the Hubble law, according to which v equals to hr, where h Hubble's constant. Looking at this figure, we can see that if a galaxy distant from the Earth by r1 has a velocity of v1, and distant by higher distance r2 has a greater velocity v2, that means that between the distances r1 and r2, the galaxy must have accelerated from the velocity v1 to v2. So we can draw the following conclusion. Galaxies are accelerating, and this statement is wrong. That's the topic of this presentation. Our mistake is that we are describing the problem from the point of view of an observer on Earth. And just as when observing the sky from Earth, we see that the Sun is moving around the Earth, so when we observe the galaxies, we see that the galaxies are accelerating, although in fact they are all constantly moving at identical speeds. So we change the point of view and bring the observer to some indefinite point of reality. The proposed description of reality can be found in the presentation What are Time and Space, and the justification of Hubble's law in the presentation Why the Galaxies are Accelerating. But just in case, I will remind the basic assumptions of the model. The reality we live in is a four-dimensional and Euclidean. The dimensions that make up the Euclidean reality, here A1 and A2, A3, A4, do not have a pre-assigned sense of time and space. The time and space we perceive are only two ways in which we perceive reality while observing the bodies around us. All bodies in E4 move at identical absolute speed equal to 1. Here we are only talking about moving along a straight path. So bodies perceive the path traveled in E4 as the flow of time. The time axes of the coordinate systems of bodies are their trajectories in E4. Most generally, each body can interpret a different direction in E4 as the time axis of its own coordinate system. We learn about the existence of space only by observing the bodies that surround us. In the E4 model, we assume that bodies send and receive interactions in directions perpendicular to their trajectories in E4. Thus, we are able to observe all motions of bodies along the directions of propagation of these interactions, that is, along the directions perpendicular to the time axis trajectory of the observed body. Thus, as space dimensions, the observer interprets the directions perpendicular to the time axis trajectory of currently observed body. To sum up, while observing the bodies in E4, the observer interprets his trajectory as the time axis of the coordinate system, while the directions perpendicular to the time axis trajectory of the observed body as space dimensions of his coordinate system. Let us now consider the problem of galaxies receding, but not in Minkowski spacetime, but in Euclidean space E4. At the beginning, there was Big Bang. Since the Big Bang, The galaxies have receding in all directions, but note, in the E4 model, all galaxies move like the other bodies in E4, i.e. with constant absolute speed equal to 1. Finally, after time t equal to the age of the universe, all our galaxies and bodies will be in a three-dimensional hypersphere with radius t. The trajectories along which all bodies move are the time axes of their coordinate systems. The trajectories are marked as hours on the clock face from T1 to T12. Now let us consider what the observer on Earth sees. An observer on Earth, currently at 3 o'clock, interprets as space dimensions the directions perpendicular to the trajectory of currently observed galaxy. For example, for observing a galaxy traveling along the trajectory T2 at 2 o'clock, he measures the distance along the direction perpendicular to T2. And the speed of this galaxy in the observer's system equals to V equals dr2 by t equals dr2 times h equals to sine phi2, where h equals 1 by t and it is Hubble's constant. That is, the velocity is equal to the sine of the angle between the galaxy's trajectory and that of the observer. And since the angle between the trajectories does not change from the Big Bang moment, we can see that the T2 galactic speed is constant. The same is true for the galaxy T1 and for all other galaxies following trajectories between 12 o'clock and 6 o'clock. For the 12 o'clock and 6 o'clock trajectories, the angle of the trajectory relative to the observer on Earth is 90 degrees. This corresponds to the speed of 1, which is the same speed as the speed of light. However, the observer cannot observe the galaxies on these trajectories because the path of signals from the T12 and T6 galaxies are parallel to the observer's trajectory, so they will never be picked up. The same is true for all galaxies following trajectories between the 6th and 12th o'clock. None of these galaxies will be observable from Earth. So, if we assume that the galaxies send interactions perpendicular to their trajectories, then half of the universe is invisible. In this presentation, I assumed that galaxies send their interactions along straight lines perpendicular to their trajectories. This assumption was accepted to be consistent with the model of interactions propagation presented in my other works on the Euclidean space model. However, the invisible mass of the universe is much greater than half of the visible mass of the universe, so perhaps it would be advisable to assume that the interactions do not propagate along straight lines, but along curves contained in a three-dimensional hypersphere with radius t. In that case, the invisible part of the universe would be much larger than 50%. You can also consider the existence of an additional dimension or dimensions, which would cause an even greater increase of the part of the universe unavailable for observation. But that is a topic for further considerations. To sum up, the statement that galaxies are accelerating is incorrect. The dependence of the speed of galaxies on the distance from the Earth does not result from the acceleration of galaxies, but from the fact that we observe galaxies along certain directions perpendicular to the trajectories of the galaxies. In fact, all galaxies move at the same speed of 1. No acceleration of galaxies means no need to introduce any dark energy. The way of observing galaxies makes at least half of the universe unavailable for observation. The observed velocity is a function of the angle between the trajectories of the observer and the observed galaxy, and may also depend on the shape of the interaction path, straight line or arc contained in the three-dimensional hypersphere or more dimensions, etc. The same description presented in Minkowski spacetime is much poorer and does not explain as much as the description in E4. In addition, it can be seen that the description in Minkowski's spacetime is made from the point of view of an observer on Earth. That is exactly according to the same logic according to which the geocentric model of Ptolemy was made. Meanwhile, the separation of the coordinate system from the observer on Earth allowed to simplify the description of the motion of the planets, and now simplifies the description of the galaxy's recession phenomenon. If anyone has doubts about the issues of simultaneity in the space of E4 and Minkowski, which I have operated here without any explanation, then the description of the issues regarding simultaneity can be found in my publication in the International Journal of Theoretical and Mathematical Physics. Thank you, and I invite you to other presentations and publications.